Hello everyone. Today in this video we are going to learn about the chi-square test of independence. In our previous video we have done the chi-square goodness of fit. I am leaving a description here in the box so that you can see the link and you can study that and you can come back for the chi-square test of independence. There are two types here, the goodness of fit, okay, goodness of fit. It was in the previous video, and another one here, test of independence. We'll quickly move on to the test of independence, which is the chi-square test of independence. If you have not subscribed to my channel, kindly do it. We'll quickly move on to this video here. So what is a chi-square test? We have done it already in the previous video. Quickly, I'll just recap that. So it's nothing but a hypothesis testing method. There it's a single number that tells you how much difference exists between your observed frequencies and the expected frequencies. Okay, so what are the types? The two major types we are learning here is chi-square goodness of fit. This has been done already. Okay, so now today in this class we are going to find out this one, which is the chi-square test of independence. What is it we are going to study here? Okay, in the previous chi-square goodness of fit, only one variable. Here we'll be having two variables here. Okay, so here one particular point you have to remember, something called a contingency table will be given here. It is nothing but a tabular column which is just like this. Okay, so here suppose for example I'm having male, I'm having female here. This is educated, now non-educated, like this. If I have some data, I can have this as a contingency table. For chi-square test of independence, we'll be using this contingency table. Okay, right. So now what is this chi-square test of independence is about? So it is used to test whether two categorical or nominal variables, we are concerning with categorical or the nominal variables, are likely to be related or not. Okay, they are having some relationship between them or not. We are going to study in this chi-square test of independence here. It is a non-parametric test, as usual, used to test the association between two categorical variables. Okay, so now suppose for example in a clinical trial, see, suppose I'm doing a clinical trial, so it will be used to test the association between, what are the variables here? Adverse event is a variable one and the treatment used is the variable. Okay, so now X and Y, is there any relationship between this? This what we are going to study in this chi-square test of independence. This is a similar example here. Okay, now what will be the hypothesis we are going to have it here? Usually there is no relationship between the variables. That's what is the hypothesis usually we'll have. And what is the alternative hypothesis? There is, or there are, some plural also we can have it. There are relationship between variables. That's what we are going to have this as an hypothesis here. Okay, now what is the formula we are going to use it for? Okay, now the test statistic is as usual called as chi-square. We have to read it as chi-square. Okay, chi-square, which is calculated using this formula. Okay, the previous formula only. Both are using the same formula. The method of calculating the expected value is the difference between the previous one and this one. Okay, where O is the observed value, E is the expected value, and one more difference you have to watch it here. See the degrees of freedom. How we are going to calculate the degrees of freedom is R minus 1 and C minus 1. See, for example, I am having a contingency table like this. Okay, see there are two rows and there are two columns, for example. Okay, so now keep it in mind, if it is given as the total column and here a total row, we have to omit that total row and total column here. You should not take the total row and total column. Wherever is the data, that is the row and column. Okay, so now R is the number of rows, C is the number of columns. Suppose for this particular thing, it is 2 minus 1 and 2 minus 1. 2 rows minus 1, 2 rows minus 2 columns minus 1. That will give you 1. Okay, this we have to keep it in mind while calculating the test statistics chi-square here. Okay, now where R is the number of rows of the contingency table and C is the number of columns of the contingency table. Keep it in mind that total row and total column we should not take into consideration. If the total is not given, we are going to total it. Sometimes total will be given, sometimes total will not be given. If total will not be given, means just we have to calculate the total and we have to proceed. We'll be seeing one example so that you will understand here. What is an example here? See, an anti-malaria campaign in a certain area, quinine was administered to 812 persons out of total population. 3248 is the total population. 812 persons I am taking, I am giving this drug for them. Okay. So now the number of fever cases is given below. So after taking this or without taking this, the people who are having some fever are tabulated here. Okay. Now this is the treatment. Okay. So the drug is given, the drug is not given. Fever, number of people is 20. Here, number of people having fever 220 without this medicine. Okay. So now no fever is 792, 2216. See here, the total column is not here and the total row is also not here. Okay. Now, when I total this here, this is called the row total. Okay. Now, when I total this, this is called the column total. Okay. Column total. Okay. These are all the column total. Now, when I have the grand total here, this is called the grand total. Okay. As well as the row total, as well as the column total, when I have, that's called the grand total. We are going to see this now. Okay. Now discuss the usefulness of the quinine in checking the malaria. This is the question being asked. Okay. So we are going to use the chi-square test here, chi-square independence test here. Okay. So now how to do this here? First, we have to set the hypothesis. I am setting the hypothesis in my own word that this drug is not useful in checking the malaria. So now HA will be the drug is useful in checking the malaria. You can give the name or generally you can talk like the drug. Okay. So now alpha, as usual, I'm going to take it as 0.05. So in all the sums we have taken it because this is not given. So we have to take it as 0.05. So sometimes it will be taken as 0.01 also, I told you. So we can keep it in mind. Okay. So now how to proceed here? See, the expected value is calculated by the following formula. Imagine that I'm having the contingency table like this, 2 rows, 2 columns. I'm having a total here. This is called the row total. I'm having the column. This is called the column total here. Now row total and column total. Here I am having one more total that I'll call it as column total. Column total will be here. Row total will be here. Okay. Now this square I'm putting it. This is called the grand total. Okay. We have to keep it in mind. So for this particular thing, I want to calculate means that row total into column total divided by grand total will be the formula. I'm going to show it here. Okay, row total into column total divided by grand total for each value. So you should keep it in mind. I'm going to calculate for each and every value. Whichever the value given in the table, it is called observed value. Okay, it's called observed value. Whatever I'm going to calculate, it is called the expected value. So then we are going to use the same method of doing it. Okay. So now how to calculate? I'm going to see observed data. This is what is the data given. Okay. 20 is given, 792 is given, 2216, 220. Then I'm adding the total row as well as the total column here. Then I'm going to total it. Okay. Add these two and write here. Okay. Add these two, this plus this, which gives you this. Okay, now 220 plus this, which gives you this. Okay, after finishing this, you're going to total these two. Okay, now I'll write it here. You total these two, write it here. Okay, now when you total these two and these two, that is the grand total here. Okay, this I'll call it as grand total. Okay, now this is the row total and grand total. Now keep it in mind, for 20, the row total is 812, the column total is 240, then 3248 will be the grand total. For calculating, see, this is called observed value. For this observed value, when I want to calculate, see, observed value and expected value. Observed value is 20. For this 20, how will I calculate? Row total is this one, into column total is 240, then the grand total is 3248. Whatever the value comes here, I'll write it near. Okay, so otherwise I'll put a similar tabular column and write it here. Whichever is easy for you, you can follow. You can use a tabular column like this, or you can have a tabular column like the same which is given. Then you can take it from there. I'm going to draw a similar tabular column for expected value, leaving this total column here. This is what is the expected data here. How this 60 has come. Okay, how the 60 has come, I'm going to tell you. Okay, now 60, how it has come is, see, for this 20, I'm going to calculate for 20. Simply, I want to write for me to understand here. Okay, for 20, now what is the expected value? It is nothing but row total into, this is the row total for this. Okay, this is the row total and this is the column total for this. It is 240 divided by, this is the grand total. Okay, 3248. Similarly, I'm going to calculate for the other one. See, for 792, if I want, row total is 812, column total is 3008, and grand total is 3248. So whatever the value comes here, I'm going to write in this particular place. Then for 220, I'm calculating, writing here. For 2216, I'm calculating and writing here. Okay, this is the easiest method how to follow. I'm going to tell you once again. So for calculating the expected value, so I'll put in a bracket here. For 20, I'm calculating. So it's nothing but row total is 812 into what is the respective column total, respective row total. You have to keep it in mind. So it is 240 divided by 3248. Where from this 3248 is coming? From here it is coming. So I'm going to write. So my value comes around 60. So I'm going to write 60 in the bracket. Okay, usually people will write like this. Okay, so they will write here in the bracket 60. They'll write here in the bracket 180. They'll write here in the bracket 752. They'll write in the bracket it is 2256. So now this is observed value. Okay, so now whichever is outside the bracket, it's observed value. So observed value, expected value. I'm going to write observed value is 20. 20 is here, and the corresponding value is 60. So I can write like this. Otherwise, I can see from the table and I can write here. Okay, now this observed value is 20. Expected value is 60. So observed, expected. Observed is 20, expected 60. Similarly, observed value is 792. Okay, you should not change the value. You have to keep it in the mind. Okay, so this is 752. Now I'm going to do it for 220 here. 220 is 180. I'm sorry. Okay, yes, correct, right. So now for this 2216, I'm going to write 2256, 2256. And as usual, I'm going to calculate O minus E the whole square and etc. Okay, so this is how we'll calculate the expected data. So yeah, make a small correction here. So it should be E. Okay, now it should be E. See, it is expected data should be E. Okay, so this observed data is O. Expected data should be E here. Okay, so now once this is done, I am going to just tabulate it. Okay, so now this is the observed value, this is the expected value. Then I'm subtracting these two here. Okay, 20 minus 60, which gives you 40 here. 220, 180. Okay, so that also gives you 40. 792, 752, which gives you 40. 2216, 2256, which gives you 40. So strange. It is a little bit strange here. Everything is coming the same value. Sometimes it may come. Right. Now I'm going to square it here. Okay, 1600, 1600, 1600. Okay, then I'm going to divide this by this particular value. Okay, now this 1600 is divided by 60. That is what is E. So 2667. So 26.667. Similarly, this one, this one, this one. Okay, I'm going to calculate this. So how to calculate this? 1600 divided by 752. This is 1600 by 180. This 1600 by 60. Okay, now this is 1600 by 2256. It is not necessary to put to these three columns here. Okay, so you can manually, you can calculate directly, you can write on the total of this column. Okay, so I'm going to total this column and I'm going to write it here. So it is nothing but the whole value 38.396. I'll call it as calculated value of chi-square. Okay, so chi-square calculated value is 38.393. Then I'm going to calculate the degrees of freedom. I'm finding out the critical value. Where from I'm finding out the critical value? I'm finding out critical value from the chi-square table. Okay, so chi-square table. So before that, I want to calculate the degrees of freedom here. So what is the degrees of freedom? Row minus 1, column minus 1. This is the contingency table. 2 rows were there. Okay, previously I'm going to show it here. Okay, previously we were having the tabular column like this only. Okay, 2 rows and 2 columns were there. So 2 minus 1, 2 minus 1, which gives you 1 here. So my degrees of freedom is 1. Okay, degrees of freedom is 1. So I'm going to follow 0.05. Okay, chi-square 0.05 for 1 degrees of freedom. I'm going to check the value. Okay, so now my chi-square calculated value is this much. Okay, so now my chi-square critical value from the table for 1 degrees of freedom, I have calculated 3.84 and 841 we have calculated from the, we instead of calculation, I'll say we found out from the table. Okay, we found out from the table 3.841 here. I'm going to compare these two. Obviously, this is bigger. So chi-square calculated value is greater than chi-square critical. Therefore, we are going to reject the null hypothesis. 5% level of significance, we are going to reject it. So therefore, we are going to conclude with 95% confidence that the medicine, okay, quinine and fever is not independent. That means this quinine is useful in checking the malaria. This is how you will calculate chi-square test of independence. So hope you understood this. If you like this, kindly subscribe to my channel, share it to your friends, and if there is any mistake or any improvement you just wanted to intimate us, kindly put it in the comment box. Thank you very much. Have a nice day.